All right, so by now you've looked at an overview of how to solve a polynomial equation. And one skill that you need in order to do that is to be able to dividing polynomials. Okay, and you do sometimes need to use the regular old long division that you learned back in Math 100, but most of the time you can use a shortcut, which is called synthetic division. So this is going to primarily be a video on synthetic division. Right now, the reason we need to be able to divide polynomials is for this reason. Let me just use a numerical example. So like if I have the number 6 and I divide it by 2, 6 divided by 2, and that can be written 6 over 2, 6 divided by 2, and if I use the old-fashioned division symbol, 2 divided into 6, it would go 3 whole times and there'd be no remainder, right? So this is the remainder. Okay, this is the quotient. This is what we're dividing by. And then this is what we're dividing into. It's called the dividend. Okay, you don't have to memorize that, but they do use this language a little bit. All right, and then like if instead of being a 6 divided by 2, we had 7 divided by 2, could be written any of these ways. But what happens when we try to divide 2 into 7, it still goes 3 whole times, but we have a remainder of 1. Okay. And so what division can do is division can help you to identify whether something is a factor. Okay, so let me change where that goes. So this is the divisor. Okay, so since I got a remainder of 0 here, since this was a remainder of 0, then I know these two numbers are factors of 6. Okay. But then since over here, this wound up being a 1, then I know these are not factors of 6, okay? So division is one way of determining whether something is a factor, and then it also allows us to take a number and write it in factored form, okay? All right, so when you're trying to divide polynomials, then what's going to happen is you're trying to find my example. Let me pull up an example off of here. When you're trying to divide polynomials, okay, I'll do a made up one on this, and then we'll go to the worksheet. So say you're trying to divide x squared minus 4x plus 1, and you want to divide that by, x minus 2 or something, okay? Well, the old-fashioned, the long division way that we learned in Math 100 would have us take x minus 2 and write it like this, and then we'd go through long division. And so we'd say x goes into x squared x times. Have no fear, you're not going to really need to do this very much, or at all for me, okay? And then we need to do that subtraction step, which is where it's kind of tricky. We get negative 4, but then that becomes minus a negative 2x, so that's really negative 4x plus 2x, so that would be negative 2x, okay? And then I'm going to go another round. X goes into negative 2x, negative 2 times. When I multiply back, I get negative 2x plus 4, but then I need to subtract all of that, so it works really well to go ahead and change the signs so that I could think of it as an adding problem. Then these would cancel out, and then 1 and a negative 4, that would be negative 3. When I'm doing a problem like this, trying to divide, if it said to divide, okay, I kind of think of it a lot like what we did up here with these two. And that with this problem, it's like the degree of the polynomial was bigger on top. So I'm getting ready to divide and see what happens. And the way I would answer this is I would say that this is equal to x minus 2 plus the remainder over the divisor. Okay, and that's the way I would write my answer. This right here is the quotient, And see how that's just like when we had the numerical examples above it, okay? This right here is the remainder. So look where it went. It's right here. Okay, and then this right here is what I was dividing by, the divisor, and that's its location in this form. Okay, so if you back that up a little bit, what we're doing is pretty much kind of like what we did here. When we do 7 divided by 2 and we do this division problem, a lot of times we do that so we can write this as a mixed number. And see how it's quotient, remainder, divisor. Quotient, and it's really an understood plus. We just don't write the plus when it's numerical. Let me write that better. It's really an understood plus. It's really 3 and 1/2, but then we just abbreviate that. We write it as a mixed number. So when I'm dividing polynomials, a lot of times I think of it that way, that I'm trying to write it as a mixed number, okay? And so there's my quotient. I wish I hadn't used this example because they're both x minus 2, but this is the x minus 2 that goes right here. And then plus the remainder over the divisor, okay? So that's long division, but thank heavens somebody came up with a shorter process than that works really quickly, and that's the point of this video. So I'm going to show you the process here, and then we're going to work several examples on a worksheet that gives you a little more practice with it. Okay, so when you're doing synthetic division, the thing you're dividing by, see how it has an X in it when you're using long division? When you're setting up your synthetic division, you're going to put a 2 in the box. So if it's an x minus 2, what goes in the box is what would happen if you were to solve that. So 2 goes in the box. And then you look at what you're dividing into, okay? And that's the x squared minus 4x plus 1. And basically what you're doing is leaving off the x's. And so just, it's like their location tells you whether it's a squared or a cubed or whatever. So I'm going to put just the coefficients of these. So the 1, the -4, and the 1. Okay? All right, and then I'm going to go through the synthetic division process with you here. So that's the setup. So you take the coefficients, okay, of the thing you're dividing into, of the top, the numerator of the rational expression, and they go there. And also be careful, we'll find that sometimes a term is missing and you have to put in a placeholder, just like we used to have to when we did long division. And then remember that if you have a factor of x minus 2, remember what goes in the box is what you would get if you set that equal to 0. What goes in the box is really going to be what we call the root or the 0. Okay, so here's the process. This is all there is to it. You bring down the first number, okay? And then what you're going to do is you're going to grab the 2 and multiply by the 1 and then place that result in the next column over, okay? So whenever you're grabbing the number in the box, you're going to be multiplying. Whenever you go straight down, you're actually adding. So 1 plus nothing is 1, okay? So now we're ready to add these two together. Okay, and when I do that, I wind up getting -2 right here. And the biggest mistake people make has to do with their positives and negatives. So be super careful about that. Remember, when you go straight down, that was adding, -4 plus +2. Then you're going to grab the 2 again, multiply by -2, and write the result right next in the next column. Okay, that was a multiplying I did. And then I was ready to add straight down. And when I do, I got a -3 right here at the end. This -3 at the end, this last spot is always the remainder. This is where you find the remainder, okay? Where here was the remainder on that one. And then this right here, this is your quotient, where in the old way we did it, that was up there at the top. And then the 2 is related to what you were dividing by, okay? And so you have to kind of put the x's back in when you write your result. Okay, so you have to think about, okay, what I had was the problem x squared minus 4x plus 1, and I divided it by x minus 2. What I got as a quotient, that's what I get from here, happens to be, see, that would be 1x minus 2. This number next to the remainder is always the constant, and then this would be 1 over from a constant, which would be an x term. So I would get the x minus 2 because that's where the quotient would go. Okay, then plus, then I put the remainder over whatever I was dividing by. And so remember that 2 is actually coming from the factor x minus 2. So make sure that this always matches that. Okay, so that's the remainder over the divisor. So you have to know where to find those things. But the process is you're gonna find the process to be pretty quick and easy. So synthetic division, that's really what we're doing here. This process right here is synthetic division. And if you can do that quickly, you have to really be able to do it fast and accurately, and you can solve a quadratic equation quickly and accurately, then there's really nothing to solving a polynomial equation. It's those two skills that you wind up doing over and over again. Okay, so let me make that smaller. So on this one, I was looking at just an example of synthetic division. So it's just a shortcut for dividing polynomials. It cannot always be used. It can only be used when you have you're dividing by something to the first power like that, which is most of the time what you have to do in this unit. Okay, if you're dividing by something that was squared, you would have to use long division, and we'd have to review that from Math 100. Okay, and then the way to think about it is that you're trying to rewrite this, and I look at it and I see how the degree on top is bigger. So it's like you're trying to rewrite an improper fraction as a mixed number. So it's like this is an improper fraction, and I'm going to use division to rewrite it as a mixed number. Okay. Now, since the remainder was -3, it wasn't 0. Okay, that means that we don't have factors, that x minus 2 is not a factor of the numerator. Okay. All right, so what I'm going to do now is I'm going to move over to just some examples we're going to be able to work through, and primarily just for practice with synthetic division and what you can do with it. Okay, so synthetic division can be used just to do the division anytime anytime you have a denominator that is linear. Okay, all right, so let's look at these. So if you're trying to divide by x minus 5, what goes in the box is 5. So get that straight. If you have an x with something, then you need to put in the box what you would get if you were to solve, set that equal to 0 and solve. You know, using the terminology of polynomials, you want to get it not as a factor, but as a root, okay? And then you take the coefficients of the polynomial on top, what you're dividing into, and you write those down. Okay. And then you get started on the process. So this is only the second one we've done, so I won't go too fast. You add straight down, then you pick up the 5 and multiply by 4 and write the result in the column right next to it. Okay. So you get a 20, and now you add straight down, and that was -18 and +20, so you get a +2. You pick up the 5 and multiply by 2, get 10 and write that in the column next to it. I said plus there, I should have said times. Okay, so 5 times 2 is 10. We write it right there. And then we're going to add straight down. -4 plus 10, that's 6. Then we're going to multiply by 5. 5 times 6, that's 30. I'm going to write it right here. And a -30 added to a +30 gives me a remainder of 0. Okay. So now that means, that remainder of 0 means x minus 5 is a factor of the polynomial on top. It is a factor. It went in there evenly. And then, you were dividing a polynomial that was to the third power by a polynomial that was to the first power. That was x minus 5. So this is going to be a polynomial to the second power. Another way to think about it is this was the remainder. So this is a constant, which means this is an x, which means this is an x squared. So your answer to this one is going to be 4x squared plus 2x plus 6, but there was no remainder, so you don't write the plus 0 over x minus 5. That would be your answer to the first one. And that synthetic division, as you practice it, you'll get really good at it. And you need to, because you use it a lot, okay? So on this one, don't forget to solve or to think about the fact that if x plus 7 is what you're dividing by, what goes in the box is negative 7. Then you have a 1x squared, you have 13x, and 38. So you set it up like that. So this will be a 1, that'll be a negative 7. Okay, this will be a 6, that'll be a negative 42. This will be a negative 4. Okay, that's your remainder. So that means x plus 7 is not a factor of x squared plus 13x plus 38. But what I can do is I can take the quotient. And remember, the quotient comes from right here. This is the quotient. So the quotient for number 2, the way you would write your answer on this, since it actually just wanted us to divide, the quotient would be written as x plus 6. So see how that's a constant. So that would be an x, then plus the remainder over what you were dividing by. And then that would be your answer to the second one. Okay. Now this one I did because there's a missing term on top. See how it went cubed and then squared and then there's no x and then there's a 5? When you set this one up, in the box is going to be a negative 2 since you're dividing by x plus 2. Remember, you think about what would cause that to be 0. That's what goes in the box. I need to move that down just a little to have room. All right, and then you wind up taking the coefficients of the terms, and this is a trickier one than we've done. Because on top, we have an x to the third that has a 1, then a negative 1 x to the second, then there's no x, and then there's the constant 5. So this is important to make a note of. If there's a missing term, you need to put in a placeholder, okay? All right, so now we'll do our synthetic division. All right, so we're going to bring down the 1, multiply, get a negative 2, bring down the negative 3, multiply, and get 6, bring down, add straight down and get a 6, multiply, get a negative 12, go straight down and get a negative 7 there. All right, that negative 7 is your remainder. And so now your quotient has these 3 terms. So this would be a 6, that would be an x, this would be an x squared. Constant x and x squared. So it'd be x squared minus 3x plus 6 plus negative 7 over x plus 2. And that would be the way you would write it if they said to divide. They want the answer to the division problem. Whether you did it long division or synthetic, they would want that answer. Okay? All right. Now, questions 4 and 5 are just asking me to use synthetic division to determine whether or not the second polynomial is a factor of the first. In other words, does x minus 3 go into that polynomial evenly? So I could do long division, but since that's a linear factor, I could use this shortcut. X minus 3, so I put 3 in the box. Then you write down those coefficients. There were no missing terms. It went 3, 2, 1 constant. Okay. Then you go and you bring down, multiply, get a 3, add straight down, multiply, get a negative 6, add straight down, multiply, and get 15. And then there you have it, a remainder of 0. That's like 6, that's like the 6 dividing by 2 and going in there 3 whole times with no remainder. There's no remainder, so that means x minus 3 is a factor. So yes, x minus 3 is a factor because it went in there evenly. And then later, you don't need it for this question, but later, this would tell you the other factor. It would tell you that that would factor into x minus 3, and the other factor would be x squared minus 2x plus 5. Now, they don't want that on this question. They just want yes or no, and it's a yes. But that helps us later when we go on and try to solve, okay? So you might pause the video and try it and then see if you're right. Replay it and see if you finished it right. So set up your synthetic division and do it, and then check and see if you're right, okay? So I'm going to put -2 in the box. Going to run through the process. So I bring down the 5. 5 times -2 is -10. Add straight down, that would be -2. Okay. Multiply -2 times -2, that's +4. Add straight down, that's 1. Multiply -2 times 1, that's -2. Add straight down. Again, I got a remainder of 0. Okay, you don't always. That was just 2 examples where you did get a remainder of 0. And even though they didn't ask me, that really helps me get this thing factored. Because I know the other factor now would be 5x squared minus 2x plus 1. It comes from that quotient right there, okay? So this is one factor, x plus 2. This is the other one, 5x squared minus 2x plus 1, okay? All right, so let me go back to the worksheet and continue a few more examples on synthetic division. These last 3 are kind of what you primarily will do, okay? So let me take a snip of that so I can write on it. And let's work these out. So this asks me a slightly different question. Okay. All right, this one's asking me to use synthetic division to decide whether 3 is a root or a 0 of the polynomial equation or function. Okay, so what I do for that, if you are given the root or the 0, see how that's not x anything, it's just 3, then 3 goes in the box, okay? Then you take the coefficients, the -1, but hey, this one's tricky. See how it's missing the cube, so I need a 0. Then 8x squared, -1x, and a constant of 5, okay? So I'm going to bring down the first number, multiply, get -3, and then add straight down, get -3, multiply, get -9, add straight down, 8 and -9 is -1, multiply, get -3, add straight down, get -4, multiply and get -12, add straight down and get -7. Okay, because the remainder was not 0, okay, your answer to this question is no. And what you're answering is no, 3 is not a root or solution to the equation. 3 doesn't work. For it to be a solution, the remainder would have had to have been 0, okay? And even if it's a fraction, it's not really that hard. Just if you have trouble with fractions, make sure you know how to use your fraction keys on your calculator. So this one has a 2x to the 4th, a minus 21x to the 3rd, no x squareds, 3x, and a constant. Bring down the first number, and then I need half of 2, which is 1. Okay, add straight down, and I get -20. Half of -20 is -10. Add straight down, it's -10. Half of -10 is -5. Add straight down, it's -2. And half of -2 is -1. By now, you should be getting pretty good at your synthetic division if you're trying these ahead of me. And since it is 0, the answer would be yes. That means 1/2 is a 0 of the function, okay? And the language is a little different. 3 is not a root. I would use that language since it gave me a polynomial equation, where here they used the function, terminology. So that's when you throw in the word zero. Okay. And then I just wanted to go ahead and look at this one. So this one says to go ahead and solve the equation, given that 3 is a 0. So they're helping us out quite a bit. So what we would do is put 3 in the box, write down the coefficients. There are no missing terms. And we would do our synthetic division. Okay. And we know it's supposed to give us a remainder of 0. So if you don't get one, check for a sign error because they told us 3 was a 0. Okay. So now what you need to know you just did is that original equation that we're trying to solve, we basically have it factored into x minus 3 and 2x squared minus 11x plus 5. I got that from right here, okay? And I got the x minus 3 from right here. Remember that x minus 3 is a factor, then 3 is a root or 0. These go hand in hand, okay? And then this 2 minus 11 and that 2 and the negative 11 and the 5, that's what gives me this right here, okay? And so that problem, you couldn't have factored that using factoring by grouping or anything like it. So you had to use division in order to do it, and synthetic division just gives you a quick way to do it. But we're not done. Our job wasn't to factor, it was to find all of the zeros, okay? And so we wind up needing to go on from there and solve that, finish solving that. So what you would do at this point is, either x minus 3 has to equal 0 or 2x squared minus 11x plus 5 does, okay? So x equals 3, we already knew. And then here we would try factoring, or we would use the quadratic formula. So I'm going to go ahead and just factor that. That's a 5, that's a 1, I think. If I make them both negative, it's looking pretty good. Double check that, and then I would just continue setting those equal to 0. Could have used the quadratic formula here, and sometimes I'll have to. But here I get x is 1/2 or x is 5. Okay, so we knew 3 worked, but what we also found was that 1/2 and 5 were other zeros of that. Now, typically when I do the problems, I don't necessarily want to have to write that step right there. And what I normally do is recognize that this is the A, the B, and the C, and I kind of just set it up right here. I know that that's the other factor I'm trying to solve. And so that's where I normally do it. And I come in here, and if factoring didn't work, I'd use the quadratic formula, but then I would just continue from there. And I don't necessarily write all of this. So though that is a good thing to do and it makes sense, but I just want to share. Sometimes people get bogged down in how tedious, how much they have to write. So sometimes it helps just to know that what you're really needing is what solutions you get out of that polynomial, okay? All right, so that's the video on synthetic division. So now you're going to go back and look at some examples, more examples like number 8. Just going through the whole process of solving polynomial equations or finding zeros of polynomial functions. It's basically the same thing.